Hello and welcome back to another session of JaRu, a series where we read effective Java and try to convert the items we see here to idiomatic Rust. Now it's all about item 11, override clone judiciously. So clone is a very interesting thing. It's a very interesting beast, I'd say, because you're actually not supposed to really use it, especially when after you've read this text, because it's super difficult to get it right, and there's just a somewhat plainly documented way of doing it, and if anything goes wrong, and if you want to have subclasses that implement it, you have to really pay attention to a lot of stuff. So clone itself, here we have item 11 where phone number now has an added clone. I copied my item 10 to item 11, which has a phone number that has a clone already, just because I told the compiler to give me a properly behaving clone. So clone in Java by default is shadow, right? So if you call your object clone, which is this, then you get an object that has each member shadowly copied. This means that each primitive is an actual copy, whereas object types will just be, another reference to that particular object. And it uses checked exceptions, so the object underneath can throw a clone not supported exception, which is checked, but because you want to implement the clonable interface, what you have to do is get rid of that exception, because you're not allowed apparently to throw, or you're not supposed to. So you would catch it and say, well, apparently you're not expecting that something ever happens here. Yeah, well, that is that. It looks a bit funny, to say the least. In case of the phone number, this is working. There are other examples, obviously, where this might not be working properly, and that's how it is. In Rust, you don't even think about it, because clone will be everything you ever need to get an exact duplicate of an item. Technically, you can obviously manually override clone and do your own thing. But do your own thing, I've never seen a manual clone implementation yet, but probably if you use unsafe code, like if you manage your memory manually using pointers to memory, then you would have to implement clone yourself. Clone certainly is not implemented, automatically available for pointers, because if you can clone them, then you can easily alias them, and I'm not sure if you want them. I'm not sure how pointers behave in conjunction with clone, to be honest. If you look at the clone trait, which is part of the prelude of your program, you see that that's just this. Clone clones itself, clone from, clones into you. This is something I've never used. Performs copy assignment from source, but can be overridden to reuse the resources of A to avoid unnecessary allocations. So that's basically similar to a copy constructor here, apparently, kind of, even though you're not allowed to change the source in any way. Whereas obviously you can change yourself. That's as far as clone goes. And what I wonder is what happens if you do not catch this. I think if you do not catch this, we see the checked exception, and the compiler should tell us that we have to now put a throws clone not supported here, which obviously makes not so much sense, right? Let's see. Let's try to compile this. There we go. unreported exception, clone not supported, must be called or declared to be thrown. I see. So that was what I thought. That's kind of the machinery that this works with. It's a bit odd. As I said, clone is a standard member of the object, but it's protected and throws, even though apparently it's not supposed to throw that as long as you, or if you implement clonable yourself. All right. Is clone used here? Yes, clone is used here. We, in the previous session, kind of did that just to make it less awkward. So I just changed this to have just one point, then I clone it to use it as a key by value, obviously. Then I can use the reference to get the value out of there again. And then I basically keep using the point here for my for my display efforts, right? So I can use toString here and the standard formatting mechanism as well. There's also the mention of a copy constructor, which is something we definitely should have a look at. I mean, there's more about clone, but basically you're advised to not use it. It's really all, the difficulty comes in if subtypes come into play, and obviously you have to deal with the shallow copy that you get from the super clone that eventually gets returned. Also, you obviously have to cast the object, because super clone will in this case just return an object. Yeah, it's kind of a reflection-based copy here. I think it's similar to yeah, I don't know if it's similar to Python copy, maybe Python deep copy, maybe. Yeah, maybe Python deep copy it is, but I'm not quite sure. In Rust, by the way, you can only clone an object. You can only use this kind of clone if all your members or if all your fields here implement clone as well. And in case of primitives, that is indeed the case. So that's why that works nicely. So now, where's the copy constructor? Yeah, okay. Maybe I shouldn't skip ahead too much in this chapter. You also see how clone is implemented for stack type here. I never implemented a stack type because it makes no sense. In Rust, you would use a vector, and yeah, and the moment you start dealing with that, you would see that actually there is no data structure that can change size naturally. So in order to get the heap allocated stuff going, you would have to use unsafe code, which is then making things more difficult, so you wouldn't ever do that. So probably you can kind of implement it, but I wouldn't really know without using a vector, which then makes no sense because we would basically just be an adapter to the standard Rust vector, right? But long story short, doing this clone here just shows that in order to do it right, you definitely do not want a shallow copy of your elements. No, you want to clone the array, which in turn calls clone on each of the contained objects, so that these are not connected, that the clone is not connected anymore with its source, right? So this is basically all we see here. And yeah, that's a funny Java thing because it's a separate class as empty stack exception, which is unfortunately a runtime exception, so it's unchecked. By the way, let's go back to this. Yeah, because that's something I wanted to yeah, probably it's the right term, bitch about. Pop. So if the size is 0, then you get an empty stack exception. Okay. So in this case, it's a programmer error if you pop on an empty stack, but it can also, I don't know, maybe it shouldn't be expected behavior, Pop could also return null if there is no such object, right? Something could be done like that, like a marker, but then obviously you wouldn't be knowing if maybe somebody put a null object in there intentionally, and then you kind of lose information of whether something was popped or not. You would have to use isEmpty then to figure that out, obviously, but I really hate this hiddenness of exceptions. Checked exceptions is something I would totally use, because then at least it's clear what can happen and what has to be handled. This is similar to what the result type does to you. You at least have to check for an error. You can ignore the error entirely, but you have to check for it, right? This thing here, it will just terminate the program. You know, even with the result in Rust, you can terminate the program by just unwrapping on an error value, for instance, but it's clear that you do that. You know, it's clear in the client code that you do that. Here, the library code will just unwind, and you didn't even see it in the signature. You know, I kind of like checked exceptions for that reason, but maybe in practice they're hated to the guts, huh? So weird. Yeah, it's indeed funny that for such a new type here, you need your own Java class file here. It kind of, you know, that's Java. It's okay, but still not very. It's very wordy, but you know, I probably just have to get used to it. So back to the phone number here. I'm not yet done, because even though clone is there, at some point copy constructors are mentioned. Where is it? Alternatives of copying. Yeah. Copy constructors and conversion factory methods are mentioned, and that's something where Rust can help you. So that's apparently a copy constructor that's very similar to C++. I wonder how it looks like, to be honest, because I haven't seen it here. New instance. It's a factory method, a static one that takes something, could also be an interface, and then obviously converts it into a new yum. So you could also take a bar here, and if you have some data that you can use in a yum, then you will just use this. What I totally dislike is that there is no way to say, well, nobody's gonna change this yum. I mean, come on, this is so terrible. This is so unsafe by nature. And this is obviously in the entire Java world. You have no guarantees. Do I know that my yum comes out of there the way it was put in? No, you have no idea. And the code could manipulate yum and do stuff to it, which is totally terrible. And that's generally something that I consider unacceptable by now in a language that wants to be taken seriously. And, you know, I don't know how you can possibly write good bug-free code in Java, except for the fact that you don't get segfaults anymore, but have many other issues to fight with, apparently. Yeah, conversion constructors, they basically take, that was the thing, they basically take another interface and create a new thing for you. I think there is an example here. No. Well, kind of tree set, right? Hash set and tree set, so you can convert these into each other, but just saying, well, new tree set, it's kind of like a copy constructor, right? But this guy then takes a, you know, different type of thing and can use it to initialize itself. This is something we definitely want to test out, for instance, with the phone number thing here. So what about conversion in Rust, right? Conversion traits, there are two kinds. They're the consuming ones, I think. So it's all an std convert, by the way. We could actually have a look at this top level thing. From, into, which are consuming conversions. So they always take the from side and convert into something. And that's pretty interesting. So it really consumes what you put in there. And you have implementations for pretty much everything in the realm of standard things that are the standard library items. So how is it used here? Hello to string, string from hello, and this basically, well, doesn't really show that consumes this hello because it's a literal anyway and it's not used anywhere else. Let's have something like that, shall we? Let's implement this. So let's say we can convert this thing. I want to be able to convert this, use std convert from. I want to be able to convert this from a tuple. No. From a tuple of u16, u16, u16 into a phone number. So if n from, so now we should get our tuple. Do I have to repeat the type? No. I can just say, oh no, self will be the type of the phone number. So I do have to repeat the type. Do I get T somehow? How's this defined? Is it just that? Yeah. Oh, actually, wait. It's like this. No, it's not self. Now I'm confused. It doesn't provide a name here, so that would be. How does that? How can you do that without providing a name? Maybe that works with just one argument then. Let's see. It's implemented for something here, huh? From. Yeah, so into is the other way around, and it's pre-implemented for something. So that's how that looks like. From T to T, so you can always convert stuff into yourself. That's fine, and I kind of did it correctly. Self is wrong, obviously. We have this, and now we have to specify the type here again. Use 16, and we can return a phone number. And yeah, how would that look like? Well, we take T0 here. Area code is T0, then prefix is T1, and line number is T2. And that is that. That's a conversion trait, consuming the input. So now I should be able to convert my input tuple, which is this from. Let's see how we call this, huh? Actually, we wouldn't do it that way. We would say, well, here's the tuple, and we would say into, and let type inference do the work, because now we present a 1 u16 2 3 type inference. I think we'll set these to the value we have in the first field. Possibly, maybe I don't want to make it a tuple then. Maybe I want to make it a list, because then this behavior is definitely shown. U16 3, right? So that's the type, actually. And that makes more sense in our case. So now I have a U16 3 here. I want to convert this into a phone number that is the very same. It's 1 2 3. And I think we have to be verbose here and say area code is this, prefix is this, and line number is this. So that should work. Let's see if it actually does. Oh, cargo test lib. Attempted tuple, true, we have no tuple anymore. Now we have a beautiful array. So if you would have different types there, then we would use a tuple. Unable to infer enough type information about. Interesting. So that won't work. But we just We just implemented it, so it should be visible. It should be there. Sometimes it fails because the trait is not available. And I'm not sure if we even have to import it, to be honest. No. So that was useless. How do we get this to work? Unable to infer enough type information about a type that is not shown here. Okay, so it wants type annotations. Let's see. Into is, I think, the same thing, but the other way around. So it takes a self and converts into T. Huh. Maybe I mix things up here. So in theory, yeah, let's try to use from then. Let's try to use from, and type inference should understand now that on the other side we have a phone number, so it uses the right from. And it still hates it. Why would that be? I don't get it. Okay, so type annotation works like this, right? So we have a U16.3. Sorry. Yeah, that's a from part, right? That's this part that we have to provide. And what else? I think I got this totally wrong. That's unexpected. Even though I implemented this for other types before. What the heck is going on now? I mean, apparently it likes this implementation. I just seem to be unable to invoke it. I don't think that my definition here is incorrect. I think that's totally fine. Yeah, that's my type T. And I convert it, and we are happy. Should I try to implement into instead? Usually I'm used to implement from. But maybe I indeed got it all wrong. From for T, from for string. No. I do not understand. So probably this thing here is something he got by himself. I don't know which type parameter it can't guess, because after all, come on. Required by core from. And now it's interesting. You don't even see the type that it cannot infer. So let's try something else. Let's get it out of. Let's get it out of the macro there and say, okay, let P be a phone number. That's usually one way to do it. And then we say convert into this thing. That should be fine. And it is fine. That is very interesting. So that's what I expected, right? And it works. We have partial equality here. We can compare that. Why did it not work for within? Maybe it tries to invoke into itself, or something else was messed up. Okay, so it doesn't convert anything, that's good. I still don't understand what his problem was. Interesting. So type inference and everything basically totally failed within that macro for me. For no reason. Maybe it just wasn't able to understand that the right side should be a phone number, and my attempt to specialize the, or to provide the type here. And maybe it couldn't guess the right side here. Maybe it just couldn't figure it out. Because this can of course be implemented for many different targets here, and well, so this, by the way, can be self, right? So that would be a bit nicer. Yeah, so that's conversion traits. They consume always, and if they do not consume, then you have as ref and as mut. So that's basically another way to do it, but it's always clear whether it's gonna modify the source or not, or what's gonna happen to the source, as usual, right? So that's much better than what you have by default in Java in terms of safety, of course. So that shall be that episode. Thanks for watching and have a great day.